Hello, Miss Mary, Mr. Ryan, are you right?
Yeah.
Okay. So we given a string with binary 0 and 1s only. Okay. So it's a binary string. No 1 0 0 0 1 1. Okay. So we want to find out the maximum. Okay. The maximum odd binary. Odd. Okay. And wait. We want to find out the maximum binary odd binary. Okay, it has to be odd and it can have leading zero. For example, for this one, it's 1 1 0 0 0 1. Okay, it's odd, right? Because the remote is 1 and it's the maximum. Okay, another one and
What?
what's the maximum? Okay, we given a string with only 0 and 1s. And we want to find out the maximum.
Binary.
Yeah, binary. Yeah, basically. We want to come up with a number which is the maximum and it's odd number. Right? You know the odd number for binary.
You're
The
just
remote is.
basically reading the words on the board.
Okay,
You
okay.
can see them.
Okay, so give me an example.
Yeah, but you just flipped it. You
Okay.
just flipped. But the thing is, the two numbers there are different. You haven't told us what you
So
Wait
we need
number
to
is
find
different.
a maximum number of all binary.
Yeah. So for this
I
one,
wonder what it is.
It looks like it flips it.
One.
Do you just flip it around?
what do we flip it around?
Yeah, because look, for the two examples, you both of them flip around. So I'm assuming that you flip them around.
This example, the maximum odd number.
So you don't flip them around.
No, the maximum odd number for this one is 1 1 0 0 0 1 because for odd numbers in binary the rightmost should be 1, right? And for this one it's 1 1 1 0 0 0 0 1. Okay? For this one it's 0 0 1. We can have leading zeros. Come on, okay?
Great.
So 1 1 0 0, what's the answer?
1 1 0 1.
1001.
Yeah, that's what I just said.
1 1 0 1 0 0. What's the answer?
1 1 0 0 0 1.
Okay, so
Yeah, it is I. Good.
okay, so you're pretty good at this. So what's the solution?
So you get all of you collect all of the ones
Yes.
and then put one at the end and then give the rest of them to the left.
And then how about the zeros?
And then you leave and then you
Put zeros in the center.
yeah.
Okay, so that's it. Yeah, this is an easy
Oh
question.
no,
Right?
if it's just one, then you don't do anything.
Yeah, no, because we can have leading zeros. So basically we count, right? We count the number of ones and zeros.
If there's only
So
one, then
we have to put a 1.
Yeah, if there's only one, then you don't
Yeah,
do
okay.
anything.
Okay, so there's a special case, yeah? If there is no ones, right? But
then that's not a number. 0 0 0 0 0.
no, if all zeros, then you can't make such odd number, obviously. So we given this a string with at least 1, okay? At least 1 1, okay? So the solution is to count the number of ones and number of zeros. Okay, so let's say we have right, come on. So let's say we have A numbers of ones and B numbers of zeros. And if we say A is bigger than A is bigger than 0, so how do we construct such odd number? How do we construct such odd number? What do you say? What were you saying? So there are A
One
ones.
of the
Sorry?
right.
One on the right and the rest at the left.
One at the right, and okay, so this is the rightmost, and then
The others at the left.
how many ones here?
Depends on how much ones were there in the first place.
There are A ones. How much A is bigger than 0? So how much ones on
A
the?
minus 1.
That's right. And then here is 0. How many zeros?
B.
Okay, simple, right? And then what kind of data structure can we use to count the number of ones and number of zeros? What kind of data structure?
I.
The count, I was just almost saying it. What?
The counter.
The counter, yeah, okay. So define, okay, so let's say S, right? You know how to implement this, right? The S, right? So C equals counter, we just want to count S. and then A is
He did my
C
smiley face I put up.
1, okay?
Number.
A is the number of ones, B is the number of zeros,
Use my smiley face as a rubber.
and then we don't want to return A minus 1 times
That's not what
1 plus B times 0 plus
And on my foot.
1, okay? That's
It
it.
wants to be a rubber.
Look at this.
I am.
So C equals counter as we count the number of characters in a given binary string. A equals C1. So A is the number of ones, B is the number of zeros, right? Now look, C is the counter, and that's the key. Key is the unique characters. The value returns the number of times. That's how we use the counter, okay? Now we want to construct this binary string. Okay, so A minus 1 times 1, okay? And then put the zeros in the middle, and then put the extra 1. Okay, why this is the maximum? Why? Can you explain to me why? Why we construct this binary string in this way such that we can get the maximum? Why this is the maximum?
It is.
Yeah.
Why? Intuitively.
Because
A minus.
you make it odd and then you put the other ones at the most significant, the most valuable column.
Yeah, most significant bit, right? So look at the left. This is
And
most
also-
significant bit.
and
This is
also-
the least significant bit.
And also.
You also
Got
what?
some. Also, in the binary, the 1 is the only odd number.
Yes. If it's
One
odd number,
is
it
the
has to
only
be the
odd
right
number.
ones, right? It's like the
1
right
is the only odd number. That
You set that up.
no.
Okay, so yes.
Because then you'll be double, which will turn it to 2 times. It's a bit nug. Huh?
Okay, so what have you learned today?
Not much.
Not much. Okay, so can you explain the problem and solution? That's it. Just single,
So we have a string of numbers, zeros or ones, and we want to convert it to binary.
Come on.
Binary.
You just got number.
Come on.
Binary, and we want to find the largest odd number you can make with it, and the solution is to get, like Eric said, to get all the 1 to the right, all the rest of the 1 to the left, and in the center for those of how much zeros it is.
Exactly.
We want to put the ones as left as possible.
Yeah, I know. That's why I deleted. That's why I deleted.
And how do we count? How do we count the number
We
ones?
use a counter.
Okay, that's it for today. Bye bye.
Bye. That's my shoes.
Hiya.
Okay.
Hiya.
It's still recording.
Hiya. Hiya.
Okay. Yeah, bye bye.